All right, this is lesson 1.3, and this is actually working with variables on both sides. So it's still solving equations with variables on both sides. So this is the reference that I'm going to be referring to, so it's kind of helpful to have your book too if needed. So I'm going to move this, and we have our paper, problem and checking. Some of you are not checking. Make sure you do know how to check that. It really shows you if your answer is true or not, or correct. So we're going to look at example 1, and we have 10 minus 4x equals a negative 9x. So what we're looking for, this is like your balance scale, and we're looking for a number that you multiply by a negative 4, and you have 10 here, and then on the other side you're multiplying by a negative 9, you're trying to make it even. Well, if you notice here, now we have variables on both sides. So we are looking to getting all the variables to one side. And so your goal is to isolate the variable. If you notice, this has a variable term, and this is the only thing on this side is the variable term. So I'm going to go ahead and move my variable term. That's a negative 4x or a minus 4x. So I'm going to add 4x, and then you have a 10 equals negative 9x plus 4x is a negative 5x. Then this is a one-step equation. So divide by negative 5. 10 divided by negative 5 is a negative 2. So you're going to place that negative 2 in everywhere that you see at x. So 10 minus 4 times a negative 2 equals a negative 9 times a negative 2. So this is where you work the multiplication first. Do not subtract these first. Work the multiplication. Now think of this as a negative 4 times a negative 2. Negative 4 times a negative 2 is a positive 8. This side, I work this side at the same time. Negative 9 times 2. Ooh. See, this is why I caught it. That was a negative 2, because that would have been negative 18. Now it's a positive 18, and 18 does equal 18. I'm just working down. Don't bring the numbers across when you're checking. Just work one side and then the other. Okay? Now look at example 2. Example 2, which some people usually freak out about this, but the fraction ones are not that difficult. So 3 times 3x minus 4 equals 1/4 the quantity of 32x plus 56. So we have double distributive here, so we're going to distribute the 3 here. So 3x, that's 9x minus 12. Now, this is where a lot of people kind of freak out. Don't, though. It's all saying is 1/4 of 32. You're really saying 32 divided by 4. So 32 divided by 4 is 8, so you have 8x. Now 56 divided by 4, if you don't know what that is, just quickly go ahead and do that real quick on the side here. And that's going to be 14. So 1/4 of 56 is 14. Now you have variables to one side. You have variables and constants on both sides. So here's what I do here. This next line can do 4 ways. I can move the 9x, subtracting it. I can add the 12 first. I can subtract the 14. I can move the 8x. Now what I like to do is I like to move the variable terms first and keep it positive if possible. Meaning if I subtract 9x here and 9x here, I'm going to get a negative 1x, which is fine. But if I don't have to deal with a negative with my variable, I feel a little bit better about that. So I'm going to subtract the 8x. I always look to see which one is, if I move it, would it still keep it positive? Well, 9x minus 8x is x, or 1x, minus 12 plus 14. I like to bring everything down so I don't forget it. Now I move the variables to one side. I'm going to move the constants to the other. So I'm going to add 12, and x is going to be positive 26. Now I'm going to put that back in here. So here is where it gets a little tricky. So since I have multiplication here, I'm going to use brackets. So I'm going to do 3, that's that 3, bracket 3 times 26 minus 4, bracket, equals 1/4, bracket, 32 times 26 plus 56, bracket. Okay, so then work inside out. I saw some of you yesterday distributing. I would work inside out. So 3, now take 3 times 26, so 26 and 3, 6, what is that, 78? So 78 minus 4, and I can do this side, 1/4. Now 32 times 26, 32, 26, probably faster. I can understand a calculator on that. So if you want to grab a calculator real quick, I don't know where mine is. So if you would grab a, sorry, I didn't have this ready. Okay, so 32 times 26 is 832 plus 56. This is where it gets a little bit longer because your numbers get larger. 78 minus 4 is 74 times 3. And then 1/4, 832 plus 56 should be 888. Oh, that works out nice. 74 times 3, think of 75 times 3, and then minus 3 would be 222. Now we'll look at this. 1/4 of 888. That's like you're dividing 888 by 4. Well, 4 goes in 8 twice, 4 goes in this 8 twice, and 4 goes in this. So that does prove that positive 26 is the solution. This is where it gets real crazy and hairy with the larger numbers, but don't freak out about that. So it's just the basic computation addition. And I understand you can use a calculator on some of the larger number that's taking a little bit longer. Okay. Now, we're going to run into some situations, though, where we have problems like this. We're going to jump to example 3. Now, example 3 has this. We have 3 times the quantity of 5x plus 2 equals 15x. Well, if we distribute this 3 to each one, that's 15x plus 6 equals 15x. Now, I want you to look at this problem. Sorry, it's turned. I want you to look at this problem. You have 15 times some number, but you're adding 6 to this side, and you have 15 times some number here. It's like both of us starting with a certain amount of money. We all multiply it by 15, but then you get an extra $6. Are we ever going to be equal? And the answer is no. Because when you subtract this, you have 15x, you get 6 equals 0. Is that a true statement? No, that's a false statement. So this is a no solution. There is no number in the world that you can put in here, multiplying both by 15, but on this add 6 and ever come out equal. Okay? That's a no solution. That's what you want to say. Don't write false as your final answer, but there's a no solution. Now here on your checking, write oops, my light just went off. That's probably even better for you guys. N/A, meaning it's not applicable. You can't check. Don't leave it blank because I don't want you to think you forgot to check. You cannot check a no solution. I guess you could. You can put in any number and prove that it doesn't work. Okay, so now let's look at number 4. It's dark in here. Hold on, let me get this. Okay, so example 4. I can't even see my book, you guys. Oh, no, still example 3, but example 3b. Can you even see me right? Is my light on? Okay. That helps me. Example 3b. All right, so the problem here and checking here. Okay, so we have -2 times the quantity of 4y plus 1 equals a -8y minus 2. All right, so we distribute. So we have a -8y minus 2, -8y minus 2. It sounded like I repeated myself. If you look closely, notice it's the exact same variable term, exact same constant. So this looks identical on both sides. And in fact, if you went ahead and got rid of the variable term by adding 8y, you get a -2 equals a -2. And that is true. When it's a true statement, when it's identical on both sides, variable terms exact same, the constant's exact same, we call that an identity. Okay, so identity. Or you might see it called all real numbers, meaning every number you know right now through Algebra 1 are all real numbers. Or you might even see it this, infinitely, I don't even know if I'm spelling it right, infinitely many solutions. Meaning any number that you know right now will work in this case. Okay? So this is another example to where you can write NA for your checking. You could pick a number for Y and anything will work. Okay? So that's checking. I'm okay with you writing NA. All right. So this is what I want you to pay attention to, and that's what I want you to work on after you have checked your 1, 2, your 1, 1 and 1, 2. Make sure you go back to the Google website, Google Classroom, and check that. So here are the ones that you're working on. Page 23, 4 to 16 even. That's 4, 6, 8, 10, even numbers through 16. And then 19 through 27 all, and number 28. Okay, so you're checking. So just be careful though, if it's a no solution or inflame mini, you don't have to check. So it goes a little bit faster with that. Okay, that is your assignment. And Thursday, we'll have a work day / kind of a review. And then Friday, I'm going to do a quiz over all this. All right, thank you.